Celsius, also known as centigrade, is a scale and unit of measurement for temperature. It is named after the Swedish astronomer Anders Celsius, who developed a similar temperature scale. The degree Celsius can refer to a specific temperature on the Celsius scale as well as a unit to indicate a temperature interval, a difference between two temperatures or an uncertainty. The unit was known until 1948 as centigrade from the Latin centum translated as 100 and gradus translated as steps. From 1744 until 1954, 0 AA degree Celsius was defined as the freezing point of water and 100 AA degree Celsius was defined as the boiling point of water, both at a pressure of 1 standard atmosphere with mercury being the working material. Although these defining correlations are commonly taught in schools today, by international agreement the unit degree Celsius, and the Celsius scale are currently defined by two different temperatures, absolute zero, and the triple point of VSMOW. This definition also precisely relates the Celsius scale to the Kelvin scale, which defines the SI base unit of thermodynamic temperature with symbol K. Absolute zero, the lowest temperature possible at which matter theoretically would reach minimum entropy, is defined as being precisely 0 K and a 273.15 AA degree Celsius. The temperature of the triple point of water is defined as precisely 273.16 K and 0.01 AA degree Celsius. This definition fixes the magnitude of both the degree Celsius and the Kelvin as precisely 1 part in 273.16 of the difference between absolute zero and the triple point of water. Thus, it sets the magnitude of 1 degree Celsius and that of 1 Kelvin as exactly the same. Additionally, it establishes the difference between the two scales' null points as being precisely 273.15 degrees Celsius. History. In 1742, Swedish astronomer Anders Celsius created a temperature scale which was the reverse of the scale now known by the name Celsius. 0 represented the boiling point of water, while 100 represented the freezing point of water. In his paper Observations of Two Persistent Degrees on a Thermometer, he recounted his experiments showing that the melting point of ice is essentially unaffected by pressure. He also determined with remarkable precision how the boiling point of water varied as a function of atmospheric pressure. He proposed that the 0 point of his temperature scale, being the boiling point, would be calibrated at the mean barometric pressure at mean sea level. This pressure is known as 1 standard atmosphere. The BIPM's 10th General Conference on Weights and Measures later defined 1 standard atmosphere to equal precisely 1,013,250 dynes per square centimeter. In 1743, the Lyonnais physicist Jean-Pierre Christin, permanent secretary of the Académie Copyright des Sciences, Belles Lettres et Arts de l'INFR, working independently of Celsius, developed a scale where 0 represented the freezing point of water and 100 represented the boiling point of water. On May 19, 1743 he published the design of a mercury thermometer, the thermometer of Lyon built by the craftsman Pierre Cassati that used this scale. In 1744, coincident with the death of Anders Celsius, the Swedish botanist Carolus Linnaeus reversed Celsius's scale. His custom-made Linnaeus thermometer, for use in his greenhouses, was made by Daniel Extra Paragraph M, Sweden's leading maker of scientific instruments at the time and whose workshop was located in the basement of the Stockholm Observatory. As often happened in this age before modern communications, numerous physicists, scientists, and instrument makers are credited with having independently developed this same scale. Among them were Per Elvius, the secretary of the Royal Swedish Academy of Sciences and with whom Linnaeus had been corresponding. Daniel Extra Paragraph M, SV, the instrument maker. And Marianne Rte Enstra Paragraph Mer who had studied astronomy under Anders Celsius. The first known Swedish document reporting temperatures in this modern forward Celsius scale is the paper Hortus Upsaliensis dated December 16, 1745 that Linnaeus wrote to a student of his, Samuel Norrkälä copyright R. In it, Linnaeus recounted the temperatures inside the orangery at the Botanical Garden of Uppsala University. Since the colder ion by the angle of the windows, merely from the rays of the sun, obtains such heat that the thermometer often reaches 30 degrees, although the keen gardener usually takes care not to let it rise to more than 20 to 25 degrees, and in winter not under 15 degrees. Centigrade in Celsius. Since the 19th century, the scientific and thermometry communities worldwide referred to this scale as the centigrade scale. Temperatures on the centigrade scale were often reported simply as degrees or, when greater specificity was desired, as degrees centigrade. The symbol for temperature values on this scale is a degree Celsius. Because the term centigrade was also the Spanish and French language name for a unit of angular measurement and had a similar connotation in other languages, the term centesimal degree was used when very precise, unambiguous language was required by international standards bodies such as the BIPM. The 9th CGPM and the CIPM formally adopted degree Celsius in 1948. It was not until February 1985 that the forecasts issued by the BBC switched from centigrade to Celsius. For scientific use, Celsius is the term usually used, with centigrade otherwise continuing to be in common but decreasing use, especially in informal contexts in English-speaking countries. Common temperatures. Some key temperatures relating the Celsius scale to other temperature scales are shown in the table below. Name and symbol typesetting. The degree Celsius has been the only SI unit whose full unit name contains an uppercase letter since the SI base unit for temperature, the Kelvin, became the proper name in 1967, replacing the term degree Kelvin. The plural form is degrees Celsius. The general rule of the International Bureau of Weights and Measures is that the numerical value always precedes the unit, and a space is always used to separate the unit from the number, for example 30.2 a degree Celsius. Thus the value of the quantity is the product of the number and the unit, the space being regarded as a multiplication sign. The only exceptions to this rule are for the unit symbols for degree, minute, and second for plane angle, for which no space is left between the numerical value and the unit symbol. Other languages, and various publishing houses, may follow different typographical rules. Unicode character. Unicode provides a compatibility character for the degree Celsius at U+2103, for compatibility with CJK encodings that provide such a character. Its appearance is similar to the one synthesized by individually typing its two components and shown below is the degree Celsius character followed immediately by the two-component version, a florin a degree Celsius. When viewed on computers that properly support Unicode, the above line may be similar to the image in the line below. The canonical decomposition is simply an ordinary degree sign and C, so some browsers may simply display a degree Celsius in its place due to Unicode normalization. Temperatures and intervals. The degree Celsius is a special name for the Kelvin for use in expressing Celsius temperatures. The degree Celsius is also subject to the same rules as the Kelvin with regard to the use of its unit name and symbol. Thus, besides expressing specific temperatures along its scale, the degree Celsius is also suitable for expressing temperature intervals, differences between temperatures or their uncertainties. Because of this dual usage, one must not rely upon the unit name or its symbol to denote that a quantity is a temperature interval. It must be unambiguous through context or explicit statement that the quantity is an interval. This is sometimes solved by using the symbol a degree Celsius for a temperature, and car degree for a temperature interval, although this usage is non-standard. What is often confusing about the Celsius measurement is that it follows an interval system but not a ratio system. That it follows a relative scale not an absolute scale. This is put simply by illustrating that while 10 AA degree Celsius and 20 AA degree Celsius have the same interval difference as 20 AA degree Celsius and 30 AA degree Celsius, the temperature 20 AA degree Celsius is not twice the air heat energy as 10 AA degree Celsius. As this example shows, degrees Celsius is a useful interval measurement but does not possess the characteristics of ratio measures like weight or distance. Coexistence of Kelvin and Celsius scales. In science and in engineering, the Celsius scale and the Kelvin scale are often used in combination in close contexts. For example, a measured value was 0.01023 AA degree Celsius with an uncertainty of 70 AA micron K. This practice is permissible because the magnitude of the degree Celsius is equal to that of the Kelvin. Notwithstanding the official endorsement provided by Decision No. 3 of Resolution 3 of the 13th CGPM, which stated a temperature interval may also be expressed in degrees Celsius, the practice of simultaneously using both a degree Celsius and K remains widespread throughout the scientific world, as the use of SI prefixed forms of the degree Celsius to express a temperature interval has not been well adopted. Melting and boiling points of water. One effect of defining the Celsius scale at the triple point of Vienna standard mean ocean water, and at absolute zero, is that neither the melting nor boiling point of water under one standard atmosphere remains a defining point for the Celsius scale. In 1948, when the Ninth General Conference on Weights and Measures in Resolution 3 first considered using the triple point of water as a defining point, the triple point was so close to being 0.01 AA degree Celsius greater than water's known melting point, it was simply defined as precisely 0.01 AA degree Celsius. However, current measurements show that the difference between the triple and melting points of VSMOW is actually very slightly greater than 0.01 AA degree Celsius. Thus, the actual melting point of ice is very slightly below 0 AA degree Celsius. Also, defining water's triple point at 273.16 K precisely defined the magnitude of each 1 AA degree Celsius increment in terms of the absolute thermodynamic temperature scale. Now decoupled from the actual boiling point of water, the value 100 AA degree Celsius is hotter than 0 AA degree Celsius in absolute terms by a factor of precisely. When adhering strictly to the two-point definition for calibration, the boiling point of VSMOW under one standard atmosphere of pressure is actually 373.1339 K. When calibrated to ITS 90, the boiling point of VSMOW is slightly less, about 99.974 AA degree Celsius. This boiling point difference of 16.1 millikelvin between the Celsius scale's original definition and the current one has little practical meaning in common daily applications because water's boiling point is very sensitive to variations in barometric pressure. For example, an altitude change of only 28 cm causes the boiling point to change by 1 millikelvin. Worldwide adoption. Throughout the world, except in the United States, Belize, Parlay and the United States territories of American Samoa and the U.S. Virgin Islands, the Celsius temperature scale is used for practically all purposes. The only exceptions are some specialist fields where the closely related Kelvin scale dominates instead. Most scientific fields and many engineering fields use the Celsius scale, and the metric system in general. However, most Americans remain more accustomed to the Fahrenheit scale, which is the scale that U.S. broadcasters and journalists use in weather forecasting, although the equivalent in Celsius is occasionally provided alongside. Fahrenheit is also commonly used in the U.S. for measurement of body temperature, and household use such as cooking, and is the scale commonly seen on ovens and in recipes. In Canada, kitchen devices, literature, and packaging include both Fahrenheit and Celsius quotations. The United Kingdom has gradually increased use of the Celsius scale since the 1970s and it is now the predominant temperature scale used. Some broadcasters and publications quote Fahrenheit air temperatures alongside Celsius in weather forecasts while others use Celsius only. Likewise, some retailers sell air temperature thermometers that show both scales, but most now display Celsius only, and Fahrenheit only displays are extremely uncommon. Conversion table between the different temperature units. See also, absolute zero, degrees of frost, ITS 90, comparison of temperature scales, thermodynamic temperature, notes and references. External links, NIST, basic unit definitions, Kelvin, the Uppsala Astronomical Observatory, History of the Celsius Temperature Scale, London South Bank University, Water, Scientific Data, BIPM, SI Brochure, Section 2.1.1.5, Unit of Thermodynamic Temperature, Tampere, Comparison of Temperature Scales, C to F Converter, Celsius to Fahrenheit Converter.